Okay, we left off last class. We talked about simple interest. And I gave you a problem here as just an example to review, see what you remembered. Now remember the formula, interest is principal times rate times time. In this particular problem, what is the principal? So you guys are all muted on me. Somebody tell me what the principal is. I think everybody is still muted. If you guys want to just hit your mics, you guys aren't muted so I can hear you. There we go. What's our principal here? Principal is the amount of money you start with, which would be $3,200. Perfect. The rate. It's the 8%. Of course, we write it as a decimal. It's 0.08. And the time? 3 months. And that time is expressed in years, so we have to express that as 3/12 of a year. If we multiply that out, we should end up with $64 in interest. Did anybody get $64 to work out there? Okay. Well, interest is actually a little bit of an extra piece of material for Unit 1 of the course. So we're going to set that aside for now, and we're going to cover our last topic. If we get time at the end of the hour, I do want to come back and look at a couple of things on interest, because on Friday we finished up simple interest and we just started to talk about compound interest. And there are a couple of things that I think it's important for every young person to see on compound interest. So if we get some time here later in this hour, we'll come back to it. But our last topic for this Unit 1, remember Wednesday is our Unit 1 test. I sent that out about an hour ago, so your contact person at your school should have those for you. So just a couple of notes on scheduling I want to put out there. Wednesday is Unit 1 test. Friday then we'll start Unit 2. And then looking through the high school schedules, it appears, Chequamegon, you guys are not in school next Monday, is that correct?
Yeah.
Okay. You guys aren't in school next Monday, and it looks like Medford, Mauston, and Hurley, you guys are not in school next week Friday, is that correct?
Yes.
Okay. So what we're going to do is next Monday we'll talk about mixture problems. And then for you guys in Chequamegon, since you'll be gone on Monday, next week Friday, I'll circle back and I'll do that same lecture for you guys so you guys have that material as well. So by the end of next week, everybody will be evened out. And then that should take us through the end of February. It looks like Hurley, you guys are off on the 20th as well.
Yeah.
And what we'll be doing on the 20th is we'll still be talking about solving equations and algebraic problems. We'll just be going into a next level, a step more complex. And so we'll have to catch you guys up when you get back on the 22nd, and probably have to find some time for you guys to watch the video for that one to catch up. We'll do what we can to get you caught up. That should then take us to the end of February as far as any sort of scheduling problems, and we'll discuss the month of March once we get there. We were so close to having spring breaks line up in March this year. Okay, so let's finish up Unit 1 here. Our last topic in Unit 1 is Roman numerals. Roman numerals have become almost extinct. If you do any extensive outlining for English, Roman numerals are still used there, but I've seen some versions of outlining taught now that don't use Roman numerals anymore. So a lot of people are coming up through school and are not terribly familiar with them or haven't seen them at all. And all it is the Roman numbering system has digits. It's an additive system. where you take different values and you just add them together to get a number. Unlike ours, where you have place values, so the same digit can have different values depending on its location. The Romans just have a limited number of symbols that added up to create the value. And so they started out, the symbol for the number 1 is the letter I. Now, when I was growing up, I was always taught you use the capital letter I. The reason for that is, on most typewriters, I and the small L and 1 are hard to distinguish. The small I and other letters can be tough to deal with. So capitals were always more clear on the old typewriters and some of the old type fonts. Now with the more clarity, it is acceptable to use a small I for a 1. And for all of the symbols we put out here, it's going to be acceptable to use a small letter. Our number 5 is the symbol V in Roman numerals. Notice they don't have the 2, 3, and 4, and I'll show you how we get those numbers in a little bit. Then we jump up to the symbol for 10 is an X. Then it jumps up to 50, which is an L. You'll notice a pattern here. It goes on the 10s and the 5s, or the 1s and the 5s, however you want to look at it. 100 is the symbol C. If you ever watch any old gangster movies, or you may have heard it other places too, the term C note refers to a $100 bill, and that's where it comes from. It's from the Roman numerals. 500 is the letter D, and 1,000 is symbolized with the letter M. Now again, I used capital letters for all these. It is acceptable now to use small letters. Those are the standard ones that we're all taught. There are a couple that I'm going to go through that usually aren't taught. One of those is for 1/2. They use a small SS. Is the symbol for 1/2. And in medical fields, in medical math, that one becomes very important because most of the dosages that we deal with when we're dealing with Roman numerals, most of the dosages that are given are relatively small numbers, so a 1/2 unit is pretty common to call out. Now you might ask, well, what happens if we go bigger than 1,000? Well, if we go larger than 1,000, they do multiples. Like a V with a bar over it, that is 5 times 1,000. The bar meant times 1,000, so that's the symbol for 5,000. Or an X with a bar over it, that's 10 times 1,000, so that's the symbol for 10,000. And so on. So those bars were used to multiply by 1,000. Now, M with a bar over it was 1,000,000, and they really couldn't comprehend at that time needing anything bigger than 1,000,000. So that was the largest number in their numbering system, was 1,000,000. So the way their number system works, like I said, was additive. Mostly. So if I want to create the number 3, that's just 1 plus 1 plus 1. I. If I want to create the number 7, 7 was 5 plus 1 plus 1. So VII. So that's the additive part. You take the value for each symbol and you add it together. However, if they wanted to create the number 4, based on the additive concept, it would just be 4 1s added together. And the Romans decided that was too sloppy and repetitive. They didn't like having 4 symbols together. So they made it a rule. One of the rules of their numbering system is no more than 3 in a row of the same symbol. So to express 4, since they couldn't put 4 1s in a row, they included in a subtractive quality to their numbering system. The symbols were subtracted or subtractive if a smaller value symbol came before a larger value symbol. So for 4, it was expressed IV. Because I has a value of 1 and V has a value of 5, that's a smaller value symbol in front of a larger value symbol, before a larger value symbol. So that meant it was 1 subtracted from 5, or 5 minus 1 gave us the 4. So when we are interpreting Roman numerals, we have to keep that in mind. We cannot record the value of a symbol until we look at the symbol that follows it. For example, if I have CCLXI, relatively simple number in Roman numerals here. This first symbol is C. The symbol that comes after it is also C. So I'm just going to fill in the values here. That's 100. That's also 100. So what that means is the symbol that comes after it is not larger than it. I can record it. Now this next one, I'm going to go through the check anyway, even though we don't have to because it's the same as the one before it. But the next symbol is a 50. So again, this one is not smaller than the one after it. So we're going to record its value. So we've done those two so far. The L is 50. The next one is the X, which is 10. Again, that symbol is not smaller than the one that comes after it. So we can record the 50. Now we have the X. The next one is I, which is 1. So we've used up the L. The X is not smaller than the one that comes after it, so we can record its value. So we've used up the X. Now we just have the 1 on the end, and we will add those up. So 162, that's 261 in Roman numerals. However, you can run into this. When they did the subtractive side of things, they tended not to do 5s. They only subtracted 1s, 10s, 100s. Only the powers of 10. So let's look at this one here. We have the C, which is 100. The next digit is the X, which is 10. So the C is not smaller than the next digit, so we're going to go ahead and record its value, 100. X is 10. The next digit is C, which is 100. This X is smaller, has a smaller value than the symbol that comes after it. So now we have to take those two symbols together and subtract. So 10 from 100, or 100 minus 10, is 90. So those two symbols combine to create the 90. Now they're both gone. We move on to the next one. I is 1. The symbol that comes after it is V, which is 5. So again, this symbol has a smaller value than the one that comes after it, so we take them together. 1 from 5, or 5 minus 1, is 4. So those two symbols combine to make 4. So this is 194. So there's the subtractive property for combining the digits in the Roman numerals. Now, as I said, they tended to only subtract 1s, 10s, 100s, things that were powers of 10. To create the one that always kind of seemed awkward to me was this one, XLV. The X, of course, is a 10. The L is 50. So since the X has a smaller value than the symbol that comes after it, we combine those two to make 40. Now the V is all that's left. That's a 5. So we add the 5 to it to get 45. I get asked all the time, why would they not just do VL? So we've got a 5 and a 50, so it's 50 minus 5 is 45. which seems simpler. But as I said, they tended not to do that. They tended to only subtract tens, powers of 10, ones, tens, hundreds. The reason for that was the reason they convert. And I realized that their numbering system was independent from ours. Our numbering system, or our numbers or digits, are called Arabic numerals. When we go to convert from our numerals, Arabic numerals, into Roman numerals, it seems to make sense why we wouldn't subtract fives. But they weren't doing that conversion. So the reason why that they don't do fives, I have no idea why. They just didn't do it. So let's convert a couple more here. Let's do... Let's do MMCD XCVII. So let's see what this one comes out to be. So we've got M, which is 1,000. Another M, which is 1,000. So this one is not smaller than the digit that comes after it. So I'm going to use its value. C is 100. So again, this one is not smaller than the digit that comes after it. So I can add in its value. So the C is 100. D is 500. So there the C is smaller than the digit that comes after it. I have to take the two of them together. 500 minus 100 is 400. Goes in there. XC, X is 10. C is 100. So again, I have to do 100 minus 10 is 90. So that goes next. Now I might ask, why didn't we do, instead of doing 90, taking the 500 minusing, subtracting 100 and adding 90, why don't we just take 10 away from the 500 to get 490? Well, again, they tended only to go one level of magnitude down. So from the M and the D, from the 1,000 and 500, they would only subtract the hundreds. From the 100, they would only subtract the tens. They wouldn't subtract a 1 from 100. So for a 99, they would not take 1, they wouldn't do IC and subtract 1 from 100. They would only subtract tens from the 100s. So we've got the V here, that's 5. The next digit's an I is 1. So that V, value of 5, can be brought down. Then we just got 1 and 1. So I'm just going to put those in together as a 2. So 5 and 2 is 7, 9, 4 and 2. So 2,497. A couple of places where Roman numerals are still used outside of medicine. A lot of times on copyrights. If you look in books or on movies, a lot of times you will see a copyright date given. Quite often it'll start out as MCM. Then it might be XCII. So that would be a common copyright date for a movie or a book. I want you in your notes to see if you can convert that from Roman numerals into our standard numerals for me quick. I'll give you a minute to give that a shot. Okay, so M is 1,000, C is 100. So that M is safe to write down. It is not smaller than the digit that comes after it. C is 100, this M is 1,000. So again, the C is smaller than the digit that comes after it, so we have to combine those. 100 from 1,000 is 900. X is 10, C is 100. So again, the x is smaller than the digit that comes after it, so we combine those. 10 from 100 is 90. Then I and I is 1 and 1, or 2. That is 1992 would be the date that that is expressing. So on a little bit different note, smaller numbers, for some reason, they tend to use small letters rather than capital letters. At least that's the modern version. They used to use a capital for all of them. But IXSS, let's break down what that means. I, of course, is 1. X is 10. So again, that's a 1 before a 10. So it's going to be 10 minus 1 is 9. Those combine for. SS, now a lot of people get confused. They're used to only one digit in a Roman numeral equals 1 digit in the Arabic numerals. But both S's combined together, that is 1/2. So 9 1/2, that is 9 1/2 is what that is calling for. So that might be milliliters, milligrams, micrograms, whatever. Now, one thing that is kind of tricky when we're dealing with Roman numerals, in the medical field, if they prescribe something with Roman numerals, they tend to do this. They put the label before, instead of like if they did standard numerals, what does IV stand for? That's 1 and 5. 5 minus 1, of course, is 4. In our standard numerals, they would write it as 4 ounces with the label after it. When they use Roman numerals to prescribe a medication, they tend to put the label in front of it. So something to be careful of as you're reading some of the word problems, you will run into that notation. By the way, since it came up, IV here, if you ever hear the phrase Ivy League for schools, it's the Cornell, Yale, Harvard, and Brown. Has nothing to do with what grows on their walls or anything like that. It comes from the Roman numeral for the number 4, IV. There were the 4 main schools that were in the Ivy League. Okay, so let's look at going the other way. If I give you standard numbers, or our numbers, decimal numbers, can we put them into Roman numerals? Well, before we move on, does anybody have any questions on converting Roman numerals into standard numbers? We feel okay about it? Okay. So converting our digits into Roman numerals. So let's take 2,894 and convert it into Roman numerals. We will take each digit at a time. So the 2 here is 2,000. That has to be split up into 1,000 and 1,000. So 1,000, of course, is M. So that'll be MM. Next, we look at the 8. 800. Well, 800 is going to be split into 500 plus 3 100s. We can't have 3 in a row. We could not have 4 in a row. So 500 is D, and then C, C, C. 90 is where we have to work a little harder. We cannot do 50 plus 4 10s. That won't work. So we have to do 100 minus 10 to get 90. So that's where we're going to do XC. And then for the 4, again, we can't do 4 1s, so we have to do 5 minus 1, which is going to be IV. So 2,894 is MM for the 2,000, DCCC for the 800, XC for the 90, and IV for the 4. When we're converting from our standard numbers into the Roman numbers, it's a little bit easier to see why they only subtract the 10s instead of the 5s, because you don't know what the next digit is as you're converting. And notice I said there's 5 C's here in this number, but there's only 3 in a row. It's not that there's 4 C's in the number, but there's only 3 in a row. It's not that you can't have 4 of the same symbol in the number, it's just you can never have more than 3 of that same symbol in a row. We might have 34.5. So again, we'll take it digit by digit. 330 is going to be, I'm going to do it this way this time, 3 tens. So X, X, X. 4, we can't have 4 ones. So that's going to be 5 minus 1. So that's going to be IV. And of course, 1/2 is SS. So X, 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 IV, SS. So I want you guys to try one. 94.5. Try to convert that into Roman numerals in your notes quick. So, the 90, again, we can't do a 50 plus 4 tens, so we have to do 100 minus 10. So that's going to be XC for 90. 4, again, we can't do a 4 1, so we have to do 5 minus 1. So that'll be IV for 4. Then, of course, 1/2 is SS. So we get X, C, I, V, S, S. How many of you got that? Okay, good. Feeling pretty confident about our Roman numerals. Operations with Roman numerals were pretty sloppy. I'm going to do an example of each. An example of doing the actual operation in the numerals, but it's not a really attractive way of doing math. And I'm just going to do addition and subtraction. I'm not even going to try to demonstrate multiplication. Well, let's say we have M CD XXV. And I want to add to that MMC XLI. So I'm going to go ahead and I'm going to write these vertically just because that's how I am used to doing addition. Really nothing to line up because with odd numbers, it's the place value. The location tells you what the value of the digit is. There's really nothing to line up here. What I do want to do is I want to go through and I want to highlight digits that are subtracted. So I mean digits that come before one that's a larger value. Well, M is 1,000. So that one, C is 100. So the M is safe. C is 100. D is 500. So the C is subtracted because it's the digit that comes after it is larger than it. So then I've got 10, 10, and V, and 5. So those are safe. Down here, I've got M, M. Those are safe. C is 100, so the M's are good. X is 10, so that C is good. XL, that X, it's 10 and 50, so the X comes before a symbol with a larger value. So that X is subtracted. So then we've got L and I. So we're good. So it's the only ones that are subtracted are the C up here and the X down here. Since I know they're subtracted, I'm going to use them to, if possible, if there is a digit that's similar in the other number, to cancel it out. So I can cancel out this C and that C. Because I have a C subtracted here and that one's added down there. Same with the X. I'm going to cancel out this X with one of those X's. because these x's are additive, that one's subtracted, so it cancels out. And now I can just gather the symbols together. I have an I have a V. I'm going from smallest value to largest as I move right to left. I have an X. I have an L. All my C's are gone. I have a D. And I have 3 M's. Then I double check to make sure I don't have, more than 3 of any symbol in a row, and I don't. Let's double check my math here. This would have been 1,000. 100 from 500 would be 425. This would have been 2,000. 100. X from L would be 41. If I add that together, I get 6,653, 3,566. Let's check and see. This is 3,500. That's 50. 10 is, X is 10, so 50 and 10 makes 60. VI is 6, so it is 3,566. I did kind of a sloppy job of converting that one, but it does work out. Realistically, if I'm asked to add Roman numerals, I'm going to convert them, standard numbers, add them together, and then convert them back. I don't think I'm going to show you subtraction, because subtraction is just a matter, it deals with double negatives, they call it contrapositive logic or whatever. But you're taking the ones that are subtracting and making them positive, and the ones that are adding and making them negative, and combining symbols the same way. I think we're going to stay away from that for right now. If I were to ask you on a test to do any operations with Roman numerals, I would expect that you would convert them to standard numerals, do the operation, and convert them back. So here, for our last 10 minutes or so here, I want to take some time to look again at that interest concept, and more specifically, compound interest. And we looked at our percent increase problems that we had back in Friday. And if we had something that was increased, let's say 4%, what that meant was we had the original 100% plus an additional 4%. So what we're dealing with is 104%. And that's kind of the principle that compound interest works on. Let's say we have an investment that's going to gain 8% compounded quarterly. Quarterly means how many times a year? 4 times a year. Or every 1/4 of a year. So what that means is, since the interest is figured in every 1/4 of a year, the amount of interest in a quarter is going to be the principal, times our rate, which is the 0.08 for the 8%, times 1/4, which is a quarter of a year. If I look at this, if I combine my 0.08 and my 1/4, I get 0.02. That corresponds to 2%. The amount of interest you get every period is equal to the annual rate divided by the number of periods in a year. 8% divided by 4 is 2% per quarter. Now, the example that I really want to show you involves the power of being young. Right now, you're all in high school, so I'm assuming you're 18, 17, maybe even 16 for some of you. When you look at retirement and retirement accounts, IRS regulations allow you to start putting into an IRA, which is an individual retirement account, is what that stands for, starting at age 16. The only clause is you cannot put in more than what you earn. So if you have a part-time job and you make $1,200 this year, you can put up to $1,200 into a retirement account. If you have a part-time job and you make $6,000, well, I believe you're limited to either $5,000 or $5,500, depending on the limit changes every year. There is a maximum you can put in no matter how much you make. But let's just say you make $2,000 this year and you're let's do 17 years old. You make $2,000 and you put that away. Now, I realize a lot of you, if you have a job, you're working for gas money and maintaining a car and stuff like that. You don't get to take every penny you make and put it away. So hopefully you make more than $2,000, you can come up with a little bit to put away. Retirement, what's been published right now for people my age, I'm 43 years old, I will not be able to retire until the age of 67. I won't be able to draw full Social Security until 67. For you guys, it's going to be slightly older than that. There's a formula that's involved. But let's just say you can do it at 67. So that is 50 years in between there. Between now and when you can retire. The average gain in the retirement market, if you're invested in as long as you're not invested with CDs and stuff like that, if you actually go to an investment counselor and get into a mixture of bonds and mutual funds and stocks and stuff, even in some of our worst years, like 2008, 2009, where the market, some people lost 30% of their investments. Even periods that include those years, the average annual gain over a 40-year period is between 12 and 13%. So we're going to go conservative, and we're going to say 10% gain each year. And we're only going to compound once a year. So what that means, 10% gain, that means at the end of each year, you have 110% at the end of the year. So 110% is 1.10 as a decimal. So every year you're going to take that principal and multiply by 1.10, 110%. And we're going to do that for 50 years. So that's to the power of 50. So that $2,000 that you invest at 17, compounded at 10% per year, so 1.1 for 50 years, so the power of 50. Before I hit equals, does anybody want to guess what this is going to come out to be? Anybody want to guess more than 50,000? More than 100,000? A couple of you? Okay, well, it actually comes out to be $235,000. $234,781, we'll call it. Actually, 782 if we're rounding off. So that $2,000 at 17 years of age, if properly invested and left there until you retire, should be between $200,000 and $250,000. Now, let's say you decide, I'm going to hold off, I'm going to spend that money on whatever. I'm going to come back when I'm 27 years old. Well, this formula now changes. The 2,000 is the same. Let's say invest the same $2,000. What changes is it's only there for 40 years. So if we change that 50 to a 40, anybody want to guess? Is it still going to be more than 100,000? How many say yes, still more than 100,000? Yeah? It should be right around 100,000, about 90,519, we'll call that. So by waiting 10 years it's cut almost down to a third. It's cut way more than a half. Almost down to a third of what you would have got if you'd have started 10 years earlier. Let's say you continue to wait till you're 37 years old. Well, now that's only going to be 30 years. You're only going to get about $35,000, $34,899. It's only about $35,000. Each 10-year period you wait basically cuts it down to close to a third of what you would have had 10 years earlier. Now that's just investing that money once. Take a look. We've got a couple minutes here, so I'm going to take a look at a quick spreadsheet. Let's just look at your age, investment, and balance. And we're going to start out at, let's start out at 18. What the heck? We'll go up to 67 here again, which we're going to assume is your full retirement age. And we're going to assume you're only putting away $2,000 a year, which, like I said, once you're out and employed, you can put up to $5,000 or $5,500 a year. And we're going to stick with just the 10%. We're going to format this to be money. So if you put that $2,000 away every year, starting at 18, going to 67, anybody want to guess? How many say more than $1 million? A few of you? It's actually going to be considerably more, about 2.3 million. Now here's the interesting part, and then I'll let you guys go. I realize starting to invest for retirement at 18 isn't necessarily practical. So let's push this back. Let's say you start investing once you get through college, you're 24, you're out of college and you start to invest. You put away that $2,000 every year from 24 to 32. And then after 32, you say, you know what, I'm done investing. You don't put another penny away till you're 67. You still have over $750,000 there. So that was starting at 24 going to 32. Here's the one that always gets people because it's so drastic. This person over here says, you know what? Not only am I not going to start at 18, I am not going to start putting any money away until after I'm 32. So this person here put away that $2,000. If you count that up, that's 9 years in a row. This person here started at 33 and put that $2,000 away every year for 35 years. So who do you think is going to be ahead? The one on the left or the one on the right? How many people say the one on the left? So 2,000 for 9 years or 2,000 for 35 years. Well, if we go down here, this person that put away for just the 9 years in their 20s is way further ahead than this person that put away $2,000 a year for 35 years. So something to consider about that first 7 or 8 years of your life when you're able to start saving is worth more than the rest of your life. Okay, it is that time. So homework is out of the book, page 39. 1 through 12 is dealing with the Roman numerals. And then Wednesday is our test for Unit 1. You guys have a great day. Thanks.